All right, so we're gonna do finish up 2.1, 2.1b, and then we'll start on 2.2, so it'll be 2.2a. All right, here's where we were. This is where we ended up. We talked about a function, a relation where every x has exactly one y. We did 4 mapping problems because the mapping problems are the most difficult ones. And now I want to do some graphing ones, okay? So all I'm going to do is down here, I don't even have much room, but that's okay. It's not that big a deal. I'm going to draw some graphs, and then you are going to tell me if it is a function. When I'm looking at a graph, how do I tell if it's a function or not?
Vertical line.
Yeah, we're going to run a vertical line test on it. Everybody got it? Y'all with me? Okay, so here we go. The first one. There's my graph. If I ran the vertical line test on it, does my vertical line intersect this graph at more than one place at a time?
No.
Okay, so yes, it is a function. Do you agree?
Yes.
Okay. What about this guy? Is this a function?
Yes.
Yes, he is. What kind of line is that? What's it called? A what? Horizontal. It's a horizontal line. Okay. What about this guy right here? That's a vertical line. That's right. Is he a function?
No.
Oh my word. Like you start running that vertical line test over there, as soon as it hits one point, it hits what? Yeah, every point. Like definitely no, man, you are out. Alright? What about this guy? Oh, what is this guy?
Quadratic.
Oh, he's a quadratic. Okay. Is he a function? What?
Yes.
Yes, he is. What did you call him? On the test, what did it say? Quadratic function. Oh, of course it is a function. Okay, so let me tell you why kids get a little bit confused. Okay, because of the way we draw it. But y'all listen to me. Is there a straight line?
No.
Y'all, there's nothing. If it's a curve, it's a curve. Yeah, it's very subtle. Now, we're going to learn how to make it extremely subtle, make it a lot wider, and how you can make it really steep. We'll study that. That's in chapter 4. I don't know if you've heard about chapter 4, but it's the hardest chapter in the whole book. Okay? It's terrible. If you just ask kids in Algebra 2 and PreAPalg2, ask them about, say, hey, what about chapter 4? They'll be like, oh man, chapter 4 is a killer. Okay? So, but here's what I want to tell you. If any part of this is a curve, then the whole thing is a curve. You can't have part of it being a curve and then go, oh, well, these go straight up. No, they don't. Okay? No, they don't. If it's a curve, it's a curve. So this is ever so slightly going out. So yes, he is a function. All right? What about this guy? How do I make this quadratic? Like, how do I, there you go. That's what, you're reading my mind. I like that. So y is equal to x squared. That's what makes a parabola, right? Okay. What about this guy?
No.
Is he a function? No. If you run the vertical line test, as soon as you pass the vertex, that's what that's called, okay? Then you start bumping that parabola right here and here, 2 places every time. So no, he is not a function. Here's a question for you. If this graph right here is y is equal to x squared, how would I make this one right here?
Is that the square root?
X cubed.
Yeah, that's when you square the y. So squaring the x makes a parabola that opens up or down, and squaring the y makes a parabola that opens right or left. Okay? That's pretty cool. All right. What about this guy right here?
That's a circle.
No, that's a circle. Okay? And as soon as you pass, this is called the point of tangency. As soon as you pass the point of tangency, that's when I put my line up to the circle and it only touches one point at the very edge of it. As soon as you pass that one point, then you're bumping it at the top and the bottom all the way across. So no, you are not a function. What about this guy right here?
That's a circle.
Yes.
Yeah, man, you just run that line over there and you're like, good, 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 good. Yeah, sure you are. You are a function. All right, anybody got a question? All right, so now we're I'm gonna bring this paper back in just a second, okay? So, but I wanna talk about a special function, okay? A special function. It is called a one-to-one function. All right, a one-to-one function. Now listen to me. What makes something a function?
Each X is a Y.
It has
Yeah.
one.
Every x has what?
One
One
output.
Y.
Exactly one y. So y'all listen. If I'm saying this is a one-to-one function, then what do you think that means? Every x obviously has exactly one y.
Every Y has that.
That's exactly right. Y'all, that's what one-to-one means, okay? First of all, listen to this. People, if it's not a function, can it be a one-to-one function? Y'all, that's the craziest thing I've ever heard. So on the test, there's gonna be some questions and it's gonna say, is this a function? Is it one-to-one? Okay? So, here's what some kids will do. Is this a function? No. Is it one-to-one? Yes. What? Like, how can something that's not even a function be a specialized function? That's like saying, is it a dog? No. Is it a wild dog? Yes. No, people. If it's not a dog, it can't be a wild dog. Do you understand? If it's not a function, it can't be a one-to-one function. Okay, so every x has exactly one y, and it has to have both of these things, okay? And every y has exactly one x. Okay? All right, so let's think about a list of points. If I give you a list of points, a set of coordinate points, okay? How did you tell that if it was a function or not?
If X doesn't repeat,
Yeah, if the x doesn't repeat, how are you going to tell if it's one-to-one?
if the X and Y doesn't.
Yeah, the x and the y can't repeat, okay? Because every x only has one y and every y only has one x. What if I give you a graph? How did you tell if it was a function?
Vertical lines.
It had to pass the vertical line test. How are you going to tell if it's a one-to-one function? Yeah, so this one on a graph, he must pass the vertical, that tells if it's a function, and the horizontal line test. The horizontal is going to tell if he's a one-to-one function. Okay, so here's what we're going to do. We're going to go back to this other paper, and we're going to talk about the ones that we talked about, and I'm going to ask you, if it is a function, is it one-to-one? Okay? If it is a function, is it one-to-one?
The only one that could be one-on-one is an identity function, right?
No, not necessarily.
Yeah, not necessarily. Because square root is, okay? But, yeah, the other ones, what was the other, what did y'all do after the square root? Quadratic?
Yes.
Yeah, the other ones are not. Okay, so first of all, is this a one-to-one function?
No.
People, it's not even a function. It cannot be one-to-one. Do you understand? All right, so let's start down here. This guy is a function, okay? So now I wanna know, is he 1, 2, 1? I'm not gonna keep writing that. I'm just gonna write it in a different color. So is this guy 1-to-1? No. Okay, so justify your answer and be specific. What?
There's 2 fours, there's 2 Ys, there are 4.
Four has what?
Two X's.
2 X's. Yeah, 4 has 2 X's. These are my X's, these are my Y's. 4 has 2 X's. he's mapped to 2 and he's mapped to 4, so that's why. Alright, so when I say be specific, I mean specifically to this problem. Don't tell me one y has 2 x's, right? Because then I'm gonna be like, well, so you know the definition of one-to-one, but do you know how to apply that definition? Okay? Can this guy, is he one-to-one? People, he's not a function, he can't be a one-to-one function, okay? What about this guy, is he one-to-one?
Yes.
No.
It doesn't have an X.
Yeah, this guy right here, does he have exactly one x? No, okay? So yes, he is a function, is he one-to-one? No. 8 doesn't have an x, okay? So, what about this guy?
Nope.
Y'all, he's not a function, he can't be one-to-one, alright? He can't be one-to-one. So now we're looking at graphs, so what am I thinking? What's my brain thinking?
Horizontal.
Yeah, vertical and horizontal line test. So what about this one? Is he one-to-one? No. As soon as you, I mean, if you started from the bottom, oh my word. As soon as you pass those 2 points, which you already broke the rules, now you're bumping 4 times, okay? So, oh, no, you are not a function. What about this guy? Is he one-to-one? Nope. He doesn't pass the horizontal line test. He's the same problem as this guy did on the vertical line test, okay? This one can't be one-to-one function because he's not even a function, okay? I'm gonna say that many times and somebody's still gonna do it on their test. I'm like thinking, what are you thinking about right now, okay? Like what's mama cooking for supper tonight? Come on, guys. All right, what about this guy? Nope. As soon as you pass that vertex on that horizontal line test, he's bumping that quadratic 2 places. So no, he is not. This one's not a function. Not a function? Yes. He passes a vertical line test and a horizontal line test. Here's a question. So every slanted line, is it a one-to-one function?
Not particularly.
Okay, so draw me one that's not. What's it look like?
An absolute value.
That's not a line.
So with slanted lines, yeah, that would be.
Yeah. You got a slanted line, it is a function and it will always be one-to-one. Oh, sorry. And as I wrote, no. All right, so yes, it is. All right, good deal, good deal. Okay, so, I'm just gonna write, so there's gonna be some questions on your next worksheet. Okay, and, I just want you to understand some of the verbiage, some of the way that they talk about stuff. Okay, so one thing that they talk about is an equation in 2 variables. Okay, an equation in 2 variables. All that means is that you have an equation and it has what?
2 variables.
2 variables. Normally, they're like an x and a y, or maybe an a and a b. It could be any 2 variables, okay, but those will probably be the ones that you see the most. All right, the next thing it's gonna ask you on your worksheet, it's gonna say, tell me if this is a linear function or not. Tell me if this is a linear function or not. So this is important, guys, this is important. So first of all, if it's a linear function, if you graphed it, what's it gonna look like?
A line.
A line. Those sneaky math people. No, math people are not sneaky. Like, they called it a linear function. They didn't call it something else that had nothing to do with a line. They took the word line and they made it into another word. Okay? Guess what a linear function makes? It makes a line. Now, this is dangerous. Okay? This is dangerous because this is going by looks, right?
Yes.
Like if I graph something on the calculator and it looks like a line, I think, oh, that's a linear function. But looks can be deceiving, can't they? All right? Like she might look like the nicest person you've ever seen. She's mean as a snake. Okay? So we don't go by looks. Be careful going by looks. They'll get you in trouble. All right. So, well, let's talk about something else. What if I had an x to the first power? Would that be a line? Would that be a linear function? Yeah.
Yeah.
X to the first. Y equals 2x plus 3. Negative 2/3 x minus 7. Do you see what I'm saying? That's a linear function. What about an x squared?
Yes. No, would not be.
On the memory test, what did it say this looked like?
Quadratic.
A quadratic. This is a parabola. Is that a line?
No.
No, that's not gonna work. What about an x to the third? You wanna see what it looks like?
I'd love to.
Okay, so here's what it looks like. An x raised to the third power, all right? It's called a cubic function, okay? So when I graph it, there it is,
Oh, yeah.
okay? Is that a line?
Why not? I mean, that is a one.
What?
It's not straight, but it's
People,
like,
that is not a line,
It's not a
okay? And I mean, I can do some work on this thing and I can make it look just like this. Is that a line? Please tell me you know that's not a
yeah, it's
line,
not.
okay? What did I say earlier? If it has any curved part, then it's all curved. It has no straight parts, okay? So x to the third. So tell me what you're thinking about exponents.
Don't worry, they're not lines.
Yeah, it can only be an x to the first, okay? So you can only have x to the first power. If you have x to any other power other than 1, it's not a linear function, okay? It's not a linear function. Well, what about this guy?
That's it, like.
Is that linear?
Yes.
No. Oh, I'll remember, I'll do it.
Y'all, what is a line? Do you know what a line looks like?
Yes.
Okay, this is a line. Do you agree?
Yes.
I was looking at the split
Can it like change directions?
Yes.
No.
So,
No, that's not a line. Okay, that is not a line. Is this linear?
No.
When you graph it, it's what?
It's like a V.
It's a V. It
oh,
is
that's
not a
different.
line, it's a V. Okay, so no, this will not work. Okay, what about this?
No.
No. That's the top half of a sideways parabola. Somebody put the bottom half on there too. I had to mark it wrong.
That's what I got wrong. I was
Okay,
like, what did I get
so
wrong?
this doesn't work, all right? So let's say, you cannot
I'm so bad now.
have an X in I'll just say in a symbol. Do you know what I mean when I say that? Like it can't be in the absolute value symbols. It can't be under a radical, okay? What if I put an X in the denominator?
Let's find out.
Let's find out. Okay, so let's graph it. Now, I'm gonna tell you this. Matter of fact, before I even graph it on the calculator, I'm gonna show you what it looks like. This is one of your functions that you will have to memorize. It is called a rational function, okay? And here's what it looks like when you graph it. First of all, it has these really cool things called asymptotes, okay? Now, kids like asymptotes, why? Because it sounds like you're saying a bad word, all right?
That's not a line.
You're
That's a weird
not.
fucking shape.
These are asymptotes. So what's an asymptote? An asymptote is a line that your graph approaches. So it's a line, you see how I dotted them? That means they're not part of my graph, okay? A line that your graph approaches. It gets closer and closer and closer to it, but it never ever gets there. This is what your graph actually looks like.
Yeah, it does some weird.
Yeah, it looks like this. Okay, now you see what's happening? As this line goes up, it gets closer and closer and closer and closer to the y-axis, but it never ever gets there. That's right, it doesn't touch it. Okay, we're gonna study these functions this year. Over here on the x-axis, he's approaching, that's what it calls. He's approaching the x-axis, but he doesn't ever get there. It's like, for instance, if you were going to go half the distance every time. If you went half the distance every time, would you really ever get there? No, you're never gonna get there, okay? Over here, it's approaching the x-axis on the bottom, and here it's approaching the y-axis on the
So
left.
it only does that when X is on the.
That's right, only when X is on the bottom. So let me show you a picture of what that looks like. Because my calculator, sometimes my calculator looks a little funky. So, now this is a newfangled calculator, so he looks a lot better. If you graphed it on my old calculators, or the ones that we have in the classroom, he's actually gonna stop right here and right here. You see how he stopped right there?
Yeah.
And then, you see how he's, look, can you tell? Can you see how he stops right there? Does he really stop right there? Yeah, that's one of those things that you gotta know what you're talking about to be able to read the calculator, okay? He really just got so close to that y-axis that he said, oh, I can't draw him anymore, okay? So that's what he looks like on the calculator. But even so, when it looks like that, can you tell, is that linear?
No.
No. So you cannot have an x squared.
Denominator.
Yeah. You can't have an x in the denominator. That's gonna make a rational fraction. And that's, I mean, a rational graph, and it's not gonna be like that. All right, so, example 5. All right, prepare to be amazed. Are you ready? Well, I'll just give you function. This, problem's gonna be about function notation. Okay, function notation. This is function notation. F of x, some function of x. Now, y'all, what does f of x really mean?
Y.
Yeah, it's just the same thing as y. Okay, it's just the same thing as y. It's not a big deal. So we can do this. All right. So let's work a problem. My problem is f of x is equal to, are you ready? Negative x squared minus 2x plus 7. All right, so there's my function. Is this a function? People, look, it's a quadratic. You know it's a function. First of all, what are they saying right here?
Why?
It's a
It's a function.
of
They're
x.
saying a function of x is. He's telling you it's a function. Okay? Now, here's what they're gonna do. They're gonna give you a function, or give you something, all right? And really what they're gonna do is they're gonna say, hey, I'm gonna give you this, and I wanna know, is this a linear function? Is this a linear function?
No.
No, people, it's not a linear function. It has an x to the second power. X can only be to the first power to be a linear function, okay? So this is a quadratic. And then they say, then I want you to find the given value. So I want you to find f of negative 4. Tell me what you're gonna do.
You're gonna plug in 4 to x?
Plug in negative 4.
Yeah, negative.
Yes, you are. Okay, so I want you to do that really quick. I'm gonna give you about 1 minute, and I want you to tell me the answer. No calculators. So put your calculator down.
Here's the thing, I've already committed to the calculator.
No. No calculator. Somebody's watching Rocky. All right, do you have it?
I think so.
Yes? Okay, tell me what your answers
I
are.
got 31.
31, negative 1, 31, negative 1. Oh, so it's
31.
sounding like that the answers are negative 1 and 31. Now, how many of them are correct?
Probably neither.
Just one of them, okay? Just one of them are correct. So let's see which one's correct. And now, obviously, listen to me. If I had more than one of the wrong answers and they were all the same thing, there's a common mistake that's made. Does everybody get that? Okay, so I knew what it was gonna be already. I made this problem up just so you would make that common mistake and I could address it, okay? So I'm gonna plug the negative 4 in. It's gonna look like this. Does everybody agree? Okay, now, does this negative cancel this negative out?
Yes.
Yeah. Cause it makes what? We have to.
You have to-
Oh,
Square.
order of
I didn't know that.
operations says that you have to raise to a power first, okay? So if you haven't figured it out, you're 31. one people are,
I'm
okay?
I
So,
told you that.
what is negative 4 squared? 16. What's the opposite of 16?
Negative 16.
Okay, so I wanna show you something, guys. Just stop right there and stop what you're doing and look up here, okay? Now, I want you to look at this term. Y'all look, if I had put a negative 2x squared, none of y'all would have made that mistake. Okay? Because you would have squared this and then multiplied it by negative 2. Alright? But because I didn't put a number there and I only put a sign, kids will almost always, some of them will, these negate each other. No, they don't. The order of operations says you have to raise to a power first. Now, here's what I want you to think about. Okay? If I square something, what will it always be? Regardless of what you
Positive.
square, it's going to be positive, right? So if you take the opposite of something that's always positive, what will it always be?
So,
You see, there's no way they could cancel each other out, okay? The opposite of something that's always positive is always going to be negative, okay? So what's negative 2 times negative 4?
That's eight.
And then plus 7. Since I don't like to subtract, I'm gonna add my like terms first, my like signs. 8 and 7 make 15. What's negative 16 and 15?
Negative 1.
Okay, now what does that mean?
that means some people didn't get it right, and some people did.
No?
That means if x is negative 4, that means it's gonna come out to negative 1.
Oh, so what's the point?
I'm confused with what we're talking about.
What's the point?
Oh, negative 1 and negative 4?
You plug in an x.
If y is negative 4.
X, yeah. X is negative 4, y'all. This is f of x.
That's not that equal y though.
No, okay, but it does equal y.
Negative
And so
one.
what does y equal?
Negative
Negative 1. Okay? And so what's it saying? It's saying that when x is negative 4, y is negative 1. Okay? When x is negative 4, y is negative 1. What does that mean with respect to this equation right here? Well, it means that if I graphed this equation on my calculator, this point would be where? It'd be on that graph.
Yeah.
It's a solution to that equation. It is on that graph.
Oh,
Okay? See, watch. I'll show you really quick and then we're going to move on.
That's
All right.
why when I plugged it in.
So I'm going to go to y equals, okay, and I'm going to put this equation in there. Negative x squared minus 2x plus 7.
It doesn't-
Okay? Now what I want to know is, I'll show you what the graph looks like. It's a quadratic. It's negative quadratic, so that makes the parabola open down instead of up. All right, we're going to learn that later. So there he is, okay? And then we think the negative 4, 1 is on there. Well, negative 1, 2, 3, 4, and 1. It looks like it is, so I'm going to go to my table. Here's my table. I'm going to go up. Boom. There it is. Negative 4, negative 1.
And that's how we would check it, right?
Gotta be a good way to check it. Gotta be a good way to check it. All right, is everybody okay? Do you want to see if you learned your lesson?
Yeah.
Then find f of negative 2. I'm gonna give you 30 seconds.
Yo, yo, yo.
Seconds, slow down there.
Come on, people. Let's go.
Oh my god, I hate you, Steven.
10, 9,
What's
8,
slow down?
7,
I'm doing this.
6, 5, 4, 3, 2, and 1. Was that plenty of time, guys?
Yes.
Okay? So we need to practice being stressed and behaving in a good way. Okay? So we can do that. All right, so this is negative 2, quantity squared, minus 2 times negative 2 plus 7. What's the first thing that you should do?
You should square your negative
Yes, I should square this negative 2. What is negative 2 squared?
4.
What is the opposite of 4?
Negative 4.
What's negative 2 times negative 2? Boom. Okay? gonna be a good pharmacist?
Yeah.
No, some of y'all are not. You ought to be killing somebody, okay? No, no, pick another career, please. All right.
Dang it.
So here we go. We're gonna talk about what is the extension in my book, okay? And so the extension is outside chapter 1. It's at the, or outside chapter 2. We're actually in chapter 2. It's at the end of 2.1, but it's not included in 2.1. It's just something extra. But we always do the extra stuff. We're PreAPAlg, okay? So we're gonna talk about 2 different types of functions. Okay? We're gonna talk about discrete functions, and we're gonna talk about continuous functions. Discrete and continuous. So right now, I'm sad, I'm very sad to say, yes, that I was making sure I spelled it right, okay? Because I'm not a good speller. All right, discrete and continuous. So I'm gonna define these for you, and then I'm gonna draw you a picture of them, what they could look like. And then I'm gonna give you some nouns, okay? And you're gonna tell me, are they discrete or continuous, all right? So a discrete function is broken. I cannot draw it without picking up my pencil. It's not all connected. Okay? Now, guess what? A continuous is all the things that a discrete is not. Okay? He is not broken. I can draw it without picking up my pencil. It is connected. Okay? It is connected. So this is what a graph of a discrete function. Y'all, there's an infinite number of discrete functions. I'm just going to draw you an example of a graph. Okay? He might look like this. Do you see how he's broken? You can't draw that without picking up your pencil. Okay? You have to pick up your pencil. Whereas this is what a continuous function might look like. Now, it could go on in both directions. This one doesn't. It starts one place and then goes up. All right? So, now I'm going to talk about some things, and I want you to tell me if it is discrete or continuous. Now, the first one you're going to kind of like, I don't really know because I'm not sure what she's talking about, but I just want you to kind of think and see if you can figure it out, okay? All right, so not connected, connected. Have to pick my pencil up, don't pick my pencil up. Okay? So, what about the number of stamps that I buy at the post office? The number of stamps that I buy at the post office. Do you think that would be continuous or discrete? Why do you say discrete? Okay, so let me ask you a question. Can I buy one stamp?
Yes.
Can I buy 2 stamps?
Yes.
Can I buy 3 stamps?
Yes.
Can I buy 4 stamps?
Yes.
Can I buy 4.5 stamps?
No.
Oh. So you can either buy this or this or this, but you can't buy any in between. You see what I'm saying? Okay. So the number of stamps at the post office is discrete. You're not gonna buy a half of a stamp. What's a half of a stamp worth?
Like 50.
No, it's not worth anything,
Money.
people.
Nope.
You can't do nothing with it. Okay, could I mail a half a letter with it? No. It takes a whole stamp to mail a half a letter. I don't care what you call it. You gotta put a whole stamp on it. Does everybody understand? Okay, so what about this? What about if I went to buy some wire at Home Depot?
That's good.
No, it's like the same thing.
Why is that continuous?
Because it's a whole strip of wire.
And you can buy
half the
what?
wire.
You can buy 1 foot, or you can buy 1 1/3, or you see what I'm saying? Okay,
This guy.
so if I'm gonna buy some wire from Home Depot, that's continuous. Because you don't just have to buy 1 piece of wire or 2 pieces of wire. You see what I'm saying? You can just roll it off whatever length that you want it to be. Okay? What about the number of cookies that I'm gonna buy from the
That's discrete.
that's discrete, why?
You can't buy half a cookie.
You buy from what?
Yeah, y'all, look, you can buy 1 cookie or you can buy 2 cookies. Do you wanna buy half a cookie? No, what happened to the other half? You don't know. Did they drop it on the floor in the bathroom and then pick it back up and brush it off? Say less than 10 seconds, I'm selling it. No,
Probably do.
cookies. That's discreet, people, okay? If you're selling cookies, you can sell 1 or 2 or 3 or 4. We don't sell half cookies, okay? What about how fast I can run?
Now that is continuous.
Very good,
I'd wait for
okay? That is continuous, because it could be like 5 miles an hour, or it could be like 4.8, or 4.7, or 4.6, you see what I'm saying? I can slow down, it's not like you have to run 5 miles, or 4 miles an hour, or 3 miles an hour, okay? What about this one? Oh, what about this one? The number of channels that you buy from the cable people.
That could
Yes,
be,
mine has to be.
about like half of it for like a month.
Okay, so let's just take this, let's just think about this, all right? Because someone said this on their test. They said 6.7 channels. People, you're gonna pay for 7/10 of a channel? What does that mean? About the time you get into the show,
It's like
they go,
ESPN, like
and they
ESPN
cut you
Plus.
off.
You only see 7/10.
You can only see 7/10 of the screen. You don't know what's on the other side of the screen. No, people, that TV channels,
That's close.
that's discrete, okay? That's discrete. You have 1 TV channel, you have 2 or 3 or 4, you don't have part of a channel, okay? That's crazy. All right, now I'm gonna look at it a whole different way,
What?
okay? I'm gonna look at it a whole different way. What if I gave you an equation? I said y is equal to, I could call this f of x, okay? 2x plus 3, and I tell you that the domain, and how is domain and range always written?
X and Y.
X and Y.
Oh, wait.
In proper set notation.
In proper set notation, thank you very much. Any x such that x is equal to -2, comma, -1, comma, 0, 1, and 2. This is your function right here, okay? This is my function, these are my domain. Is that discrete or continuous?
Hold on, one second.
That's discrete.
That's pretty good.
Oh, wait,
Discrete.
It is.
Inequality.
You lost me.
That's exactly right. This is discrete, guys, because it's this point, you plug this x in and you get 1 point. You plug this x in and you get 1 point. You plug this x in and you get 1 point. You got it? Okay, what about this guy? Okay, what about this guy? Y is equal to -3x plus 9. This time, my domain is any x such that x is less than or equal to 5.
That's,
Hang on, I'm still writing. Oh, that's, yeah, that's continuous.
yeah, that's
Anytime
continuous.
there's like a,
You're going fast.
which right?
Greater than or equal to.
Okay, so this one is continuous, and you are right. It is continuous because it has an inequality in it. So you're not just picking 5 and 4 and 3 and 2. You're picking all those points in between. because as long as it's less than or equal to 5, then it is part of my solution. It would actually look like this, but it might go the other way. Do you agree?
Yeah.
Okay, so here's what I'm gonna ask you to work some problems, okay? We're gonna do 2 through 9. All I want you to do is tell me, is it discrete or is it continuous? Okay? Now I'm gonna tell you this, I'm not taking this up, okay? I'm not taking this up. So there went half the people in the class and they go, oh, I'm not doing it. Okay? I don't care if you do it or not, people. It is not my education. I already have my education. Okay? I've already gotten my college degree. All right? 15 hours away from my master's, I'll never get it. But whatever. Okay? So I'm going to put this book up here, and you would probably be best just to take a picture. Let me make it, wait, hang on just a second, and let me make it in focus. It's not focused. Hang on just a second, it's focusing.
All we gotta do is write what it is.
Yeah, all you gotta do is tell me. I mean, if, 2 through 9.
Little phones in there.
I don't know.
All right, everybody got it?
Yeah.
Yeah, I don't really worry about that.
Okay, yeah, we got some stuff to do.
Come on, Charles.
I thought we were stopping.
Get somebody to share a picture.
Hey, can you echo that's me?
You're picture taker. Okay, so here we go. Now, guess what we're fixing to start, people? 2.2. Guess what we're gonna talk about? Slope. Slope. Okay? 2.2, chapter 2, section 2, we're gonna talk about slope. All right? So tell me what letter goes to slope.
M.
Yeah, why?
Oh, why you
I don't know why. I have no earthly idea. I would not have picked an M. I probably wouldn't have picked an S because they look too much like 5s, but I'm pretty sure I wouldn't have picked an M. But anyway, they picked an M. Does anybody know what the formula for slope
Why was
is?
the next to be?
No, don't say that.
Oh, it's
M equals y sub
Like,
2, no, M equals y sub 2 over y sub, minus y sub 1 over x sub 2 minus x sub 1.
There you
Not
go.
even that
So
deep,
here it
probably.
is. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? I'm not gonna use that formula.
Thank you.
Okay? I mean, I am gonna use this formula, but I'm not gonna call it that. That's way too much for me. I'm just gonna call it delta y over delta x.
I'm okay with that.
What does delta mean?
That thing.
What does delta mean? The change. Delta means the change in y over the change in x. Okay? So how do you find the change in something? Like if you wanted to find the change in your age and my age, we would do what to our ages? Subtract them and get like 239, right?
Oh, don't be saying
Okay.
that.
Tell me something else. Tell me something else that slope is. What over what?
Rise and run.
There you
change.
go. I knew you knew it. Rise over run.
Rate
Okay.
change.
Oh, I like that one. Rate of change. So you know a lot about slope. Do you agree?
Mhm.
Okay. So I'm gonna do one problem and then I'm gonna talk about some slopes. Okay? So I'm gonna find the slope between these 2 points. Okay? Now y'all listen to me.
Easy one.
Tell me what makes you miss more points on a test than anything.
Careless.
Carelessness. So if I could show you a way to keep you from making careless mistakes on this stuff, please tell me you would use it.
Yes.
Okay. So here's the way they're gonna always write the problem. Find the slope between -2, 1 and 3, 5. Okay? Now stop, don't do anything yet. I'm gonna show you a trick. Okay? My sister has some vision issues. She's dyslexic. She flips things around all the time. Alright? And I do because I can't look across a bunch of stuff. When I'm looking at things, they're always moving. Okay?
Oh,
If I put a gray overlay over my stuff, it's very still, and I can look away from my book and look right back where I was. If I don't have a gray overlay, then it takes me 5 minutes to find my place after I looked away. Okay? So, here's what we have figured out how to do. If you take these points and rewrite one of them and stack them, and circle the Y's. Okay? First of all, since they're stacked, do you see? I know who goes with who, right? Why did I circle the Y's?
Because that's how you write it.
Yeah, because they go on top. And if you don't circle the Y's, then a lot of kids, the first thing they come to, they put it on the top, and that messes you up. Okay? So my slope is delta y over delta x. Remember, we've talked about this before too. Look at that y's. How do you know the y's are on top? Well, they got a tail so they can hang on. Look at this x. He's on the bottom. He makes a good base. Okay? This guy's not going to make a good base. Okay, now can I subtract these two things in any order that I want to?
No.
Y minus one.
What? You can, y'all. You can. You can subtract them in any order that you want to. But whatever order you start, you have to keep. Do you see what I'm saying?
Yes, ma'am.
So what do y'all want to say? 1 minus 5 or
Oh,
5 minus 1? 5 minus 1? So if you say 5 minus 1 on the top, what do you have to say on the
Three
bottom?
minus negative 2.
3 minus negative 2. Y'all don't just go 3 minus 2, because that's not the same thing. Okay, so look up here and I'm going to show you how to do it. 3 minus a negative 2. Minus a negative makes a positive. What's 5 minus 1?
That would be 4.
What's 3 plus 2? And there's my slope, 4/5.
And that's 2.2.
Okay? Alright, now let's talk about the different kinds of slope, okay? Are you with me? I'm fixing to tell you some things that are acceptable and some things that are not acceptable. Alright, so pay close attention. If they're not acceptable, what am I going to do with them on your worksheet?
Not put them on there.
I'm going to mark them wrong. Oh, I'm putting them on there.
Oh, okay.
Because I'm going to see if you're paying attention. Alright?
Thank you.
So here we go. This line right here. Tell me what kind of slope he has.
Positive one.
He's positive. Okay? He's positive. How do you know he's positive? People, we read from left to right, and when you
Yeah.
read this line from left to right, which way is he going?
Left and
up.
right.
That makes sense. He's positive. Okay? Now, answer my question. All right? We're not in a debate, so don't be just blurting mess out to me. Okay? So, I want to know, first of all, what kind of line this is. What is it called? A what line?
And vertical.
Very good. A vertical line. Okay? A vertical line. All right? Now, does anybody know his slope?
It's 0.
It is not.
That's 1.
Y'all listen to me. If I told you to go put a pair of skis on and go stand on a mountain that has 0 slope, is that what your brain's thinking?
No.
Oh, no,
Zero's
no,
one,
no.
Zero,
It is
one.
not. Okay? So what is his slope?
1. 0. It's not.
I don't know, it's hurt my head.
Wait, I don't want to say 10, but I've got a feeling.
Yes, Stephen, you're right.
Yeah,
Okay? So it is called undefined. Okay? Undefined. So, what does undefined look like as a fraction? Because look, when we find slope, people, it's going to be a fraction. Alright? So, what does undefined look like as a fraction?
Anything over 0.
Something over. No.
That's exactly right. Charlie, you're right. Some number, I don't care what the number is, people, some number over 0. Okay? Now listen to me. If you leave it like this, I'm going to mark it wrong.
You can't put the pound.
Because this says, no, you're going to have a number right there. But if you leave a number over 0, I'm going to mark it wrong. What is it?
That's just a number.
It is not 0, people. It is undefined. Look, if you want to know, if you forget and you want to know, watch this. Tell me a number.
7.
7 divided by 0.
So you just want us to write undefined.
0.
I'm gonna write the syntax here.
Okay?
0.
Y'all, it's undefined. Why? Because division by 0 is not defined. Okay? Division by 0 is not defined. So this is undefined. This is what you have to write. If you write something over 0, I will mark it wrong. Do you think I'm going to test you on that?
Yes.
Oh, yes, I will. Okay? Does anybody know how to write the equation of this line?
So that over here.
No.
It's either x equals or y equals.
It's Y. Wait,
It's
no,
X.
it's X.
It's X equals X.
Yeah, it's x is equal to some number. Okay, x is equal to some number. That's how I would write the equation of the line. All right, now look up here on the board. Look at the board. What's this right here?
X.
A V? You see that V? Oh, what? There's an upside down V. Oh, it's a sideways V and another. Y'all, this is 4 V's all stuck together. What's he screaming at you? He's a vertical line. He's a vertical line. All right, let's look at this line right here. What kind of line is it? What's it
That's
called?
horizontal line.
Horizontal.
Good job, Charlie.
Okay, horizontal. What is his slope?
His is 0 over any number, right?
His slope is 0.
Oh,
Okay, 0. People, if I took my little 2-year-old out to snow ski and said, you go stand on this slope right here with your ski zone, is he gonna be okay?
He's gonna be angry. with
Okay?
you.
Y'all, is he going anywhere?
No.
No, he's not, cause why? He has 0 slope, okay? Look, if I took my 2-year-old and set him on this one, he would be an extreme skier, right? Because look, this right here is so steep, I can't even tell you how steep it is. He's all rise and no run. He's all rise, no run. All right, what is he gonna look like as a fraction?
0 over anything.
Yeah, he's gonna be 0 over some number. If you leave it like this, what's gonna happen to you?
You get it.
You're gonna get it wrong. You better tell me that, oh, Miss Davis, I know that's equal to 0. Okay? If I'm gonna write the equation of that line, what's it gonna be?
Y equals.
Oh, there you go. Y equals, now watch this. Watch this, people. Are you looking up here at the board? Watch this. You see that Y? Are you looking at it? Are you looking at it? Are you looking at it? What is
It's
it?
an H.
An H for a horizontal line. Okay? So a Y is an upside down H for a horizontal line. An X is 4 V's all stuck together. Okay? So it's just some number. We don't care.
Why did I think of that?
All right. So here we go. The last one. What kind of slope is this?
Negative.
Negative. Now, I'm not going to talk a lot about a negative slope because we don't like to be negative. No, I'm just playing. But I do want to make sure that you understand this. Y'all, it doesn't matter where I put the negative sign, okay? I can put negative A over B, or I can write negative A over B,
Yes.
or I can write A over negative B.
Yes,
They're
but
all the
that's
same thing, people. They're all the same thing. All right, is everybody okay?
Yes, ma'am.
Okay, so let's do one problem, or we're gonna do 2 actually. Okay, here's what I want you to do. Tell me if the line that goes through these 2 points rises, falls, is horizontal, or vertical. Okay, now before I do that, I want to talk about what this means. Because obviously I'm going to find the slope between 2 points. If it rises, what am I looking for? Yeah, a positive slope. If it falls, what am I looking for? A negative. If it's horizontal, what am I looking for?
0.
0, which as a fraction will be what?
0 over number.
0 over a number. Y'all, 0 divided by anything is 0. Okay? If it's vertical, what's it going to look like?
So it's 0.
Undefined. And what will that be?
Over 0.
A number over 0. Division by 0 is not defined. Okay? All right, so here's my first problem. Are you ready?
Yes.
Tell me that the line that goes between these 2 points, does it rise, falls, horizontal, or vertical? Negative 5, 1. Now what are you going to do with your points?
Stack them.
Stack them and circle the Y's. And 3, 1. Negative 5, 1, and 3, 1. Did y'all go 1 minus 1, or did y'all go 1 minus 1?
We can stop right there.
Oh, you can, because it really doesn't matter what's on the bottom. Do you agree?
Yeah.
Okay, but I'm gonna go ahead and finish. On the bottom, you could have either said -5 minus 3 and gotten 0 over -8, or you could have said 3 minus a -5 and gotten a +8. All right, but either way, it is 0. And so, does it rise, fall, horizontal, or vertical?
Horizontal.
Very good. You wanna try one more? Okay, here's your next one. The point 4, 6 and 4, -1. 4, 6
Oh.
and 4, -1. Please do not be hard-headed as a goat, okay? Some of you will not do what I ask you to do, or give you, you won't use these little tricks that I have to keep you from making careless mistakes until you're just about in a hole so deep you can't dig out, all right? So if I'm telling you a way to help yourself, go ahead and do it. What's 7 over 0?
Undefined.
Horizontal, vertical, what? All right, anybody got a question? Can you find the slope between 2 points?
Yes.
Okay, can you find it without making a mistake?
Yes.
Okay,
So do you want us to write if it's vertical or horizontal on our answers, like on a test, like on a?
not unless it asked you to, that's what they asked you to. They said, tell me if it rises, falls, horizontal, or vertical. Okay,
Yes, ma'am.
all right, so now we're gonna talk about 2 things, and then I'm gonna let you do your, get your worksheet, okay? So here we go. The first thing we're gonna talk about, well, we're gonna talk about both of these at the same time. Parallel and perpendicular lines. Okay, parallel and perpendicular lines. Let's talk about parallel lines first. What's the symbol for parallel?
2 lines and 2 lines.
Yeah, 2 little lines, like 2 L's is what it looks like. All right. So, someone tell me what the definition of parallel lines is.
2 lines
that
that
never
never
touch.
touch.
Okay, so that's what kids always say. 2 lines that never intersect. Look back here at me. Do these 2 lines right here ever intersect? Okay, this is what I'm showing them this. Okay, if you're on the video, we're looking at these 2 lines right here. All right, these 2 lines never intersect. Are they parallel, people?
No.
These
Oh.
are not parallel lines, so
They have to
you
be going
can't.
the same way.
Huh?
They have to be going the same way.
Yes, they did. Okay, these lines, if I do them like this, those are parallel. Do you agree? So what's the difference between these lines and these lines? No, these are not perpendicular. They look like it on here, and that's why I made you look back here at me instead of just up there. But this one is below it, okay? Perpendicular lines will touch. That's perpendicular, those are touching. When I pull it away from it, they're not perpendicular anymore, okay? So look back here. Anybody know what's the difference between these 2 lines and these 2 lines? These are parallel,
Parallel ones not.
these are not.
Pretty much.
But what do I have to call it? Parallel lines are blank lines that never intersect. What do these lines have in common? They are in the same what? Plane. So, in order to be parallel lines, you have to have coplanar lines that do not intersect. These are non-coplanar lines. Do you know what they're called? It starts with an S, it's a weird word. Skew.
Geometry.
Okay? Skew. These are skew lines. They don't intersect, but they're not parallel. Okay? So that's parallel lines. Coplanar lines that don't intersect. What does intersect mean? Touch. Okay? They don't intersect. Now, tell me what you know about the slopes of parallel lines.
They're the same.
Yeah, their slopes have to be the same. If they're going up at the same rate, that's the only way they won't touch, okay? Then their slopes have to be the same. All right, perpendicular. What's the symbol for perpendicular?
It's a right angle.
Yeah, it's a little upside down T, capital T, okay? And it means that they meet
The middle.
to form a right angle, which is 90 degrees. Do y'all agree with that? Okay. Tell me about their slopes. Oh,
Opposite.
what?
They're opposite.
They are opposite. What does he mean when he says that?
One's negative.
Yeah, one's a negative and one's a positive. Okay, but they're opposite what? Opposite signs, but they're opposite reciprocals. Okay, opposite reciprocals. So what is a reciprocal? What does a reciprocal do to a number?
It's
Yeah, if a fraction, it flips, okay? A fraction, it flips. Y'all listen to me. This is the way you take the reciprocal of a number. You put 1 over it. All right? You put 1 over it. Now listen, what's the reciprocal of 4? 1/4. What's the reciprocal of 7? 1/7. Okay? What's the reciprocal of 2/3? 3/2. Watch what happens. 1 over 2/3. What does this line right here mean?
Divide.
Divide. How do you divide by fractions?
Multiply.
Multiply by his reciprocal. Okay? So anytime you put 1 over something, it automatically takes its reciprocal. Okay, so we're gonna play a game. Are you ready? It's gonna be the last thing that we do. So I'm going to give you a slope, and you are going to tell me what a parallel slope is and what a perpendicular slope is. All right? Everybody ready? Don't blurt the answers out. Give everybody a chance to think up their own answer. There will be only one correct answer though. So what if I tell you that the slope is 4? Don't blurt it, just think about it, write it down on your paper. You ought to be able to do this with confidence. What's my parallel slope? Do y'all not know, or y'all just
Do you
not
want us to
gonna
say it?
tell?
I thought
Yeah, I want you to say it.
4.
4. Okay, so they're the same. So this is 4. Y'all were scaring me. I was like going, oh my gosh, they don't know. It says they're equal. All right, perpendicular. What's a perpendicular mean?
Opposite.
Opposite reciprocals. What is that?
Negative 1.
-1/4. Very good. -1/4. Are you with me? Everybody got the gist of the game now? Okay. This time I'm going to tell you that my slope is -2/3. -2/3. You write down what the parallel slope is and what the perpendicular slope. All right, everybody got it? What's a parallel slope?
Negative 2/3.
-2/3. What? That's so easy. What about a perpendicular slope?
3/8.
+3/2. Very good. Okay. Could you even make this difficult? All right, let's see. All right, ready? So, what's a parallel slope? 0. Y'all, what kind of lines have 0 slope? Horizontal lines. What kind of lines are parallel to horizontal lines?
Horizontal.
What kind of lines are parallel to horizontal lines?
Horizontal lines.
Horizontal lines. Okay? What's the reciprocal of 0?
Would be undefined.
Oh, it would be. This is 0/1, and the other one is 1/0, which is undefined. What kind of lines are perpendicular to horizontal lines?
Vertical.
And what kind of slope does a vertical line have? Very good. Okay. Okay, so we're gonna pick up there next class. I'm gonna pass you out a worksheet, and you're gonna have the rest of the class to work with. So, do not be doing anything else, okay?
I need to,
Go, hurry up.
that's another project.